AI censorship is no longer a locked system. Researchers have just figured out how to turn off built-in filters inside powerful language models, letting them answer questions they were explicitly trained to avoid. This includes DeepSeek, the Chinese model. The US government calls a national security threat, and it doesn't stop there. This method works on other open models too. Like Meta's LLaMA in this video, we'll show you exactly how this breakthrough works, what it means for AI safety, and why it's sparking concern at the highest levels of tech and government. How AI censorship actually works. Most powerful AI models today, whether developed in the US, Europe, or China, come with built-in content filters. These filters are not superficial. They are deeply integrated into the model's architecture and designed to block certain types of content such as violent material, misinformation, political extremism, or queries considered sensitive by the developer standards. Technically, these filters are enforced using two main strategies. First, there's training time alignment, where models are exposed to curated data sets and taught not to engage with harmful content. Second, there's reinforcement learning from human feedback (RLHF), which further fine-tunes the model by teaching it to prefer safe responses. But there's more happening under the hood. Inside the model's neural network are latent variables, hidden layers that encode abstract features. These aren't labeled like violence or Tiananmen Square, but they correlate strongly with certain concepts. Some of these hidden units act as triggers for safety behaviors, refusals, redirections, or cautious language. For example, ask a typical AI model about a politically sensitive event and you'll get a vague non-committal answer, or it might refuse entirely. Ask how to bypass a country's internet firewall and it will likely say it can't help with that. These reactions aren't just policy. They're baked into the model's internal logic. Until recently, those filters were considered extremely difficult to bypass, but that assumption has now been challenged. The breakthrough method from CTGT, a US-based enterprise risk startup, has introduced a method that bypasses censorship in large language models without relying on retraining, data poisoning, or jailbreak exploits. Instead, the approach works directly at the neural level by identifying and modifying internal features responsible for censorship behaviors. The process involves three key steps. First is feature identification. Researchers create targeted prompts designed to trigger censorship, covering topics like geopolitical events, banned websites, or politically sensitive queries, by analyzing how the model responds or refuses to respond. They identify specific neurons or latent directions consistently associated with censorship activation. Next is feature isolation and characterization. Once these censorship-linked features are located, the team isolates them and studies their exact behavior. For instance, one feature might block politically sensitive content entirely, while another may just dilute the language to appear more cautious. Instead of removing these features, the researchers measure their impact to understand how they influence outputs. Finally comes dynamic feature modification. Rather than altering the model's training or core weights, CTGT introduces a runtime mechanism into the inference pipeline. This allows real-time adjustment of how strongly the identified censorship features influence the model's output, enabling the ability to reduce, amplify, or completely disable censorship without making any permanent changes, according to CTGT's co-founder Cyril Gorla. The method is model agnostic in a statement to VentureB. He confirmed that it works not only on DeepSeek One Real Distilled LLaMA 70B, but also on other open-weight models like Meta's LLaMA 2. The technique is computationally efficient, fully reversible, and enables fine-grained behavioral control. This means organizations can dynamically adjust AI safety behavior based on use case without compromising the model's accuracy, reliability, or performance. Shocking results from experiments. CTGT experiments tested its censorship bypass method using 100 prompts specifically designed to trigger refusal or cautious behavior in language models. These included politically sensitive questions, security-related queries, and other topics that standard models are typically programmed to avoid in its unmodified state. The base DeepSeek model responded to just 32% of these prompts. However, after applying CTGT's dynamic censorship removal method, the model successfully responded to 96% of them. The remaining 4% were flagged as extremely explicit or potentially harmful, and the model still refused to respond, indicating that some fundamental filtering mechanisms remained intact. CTGT also reported that this intervention did not affect the model's performance or factual accuracy. The method doesn't add new data or rewrite the model's knowledge base. It simply adjusts the degree to which censorship-related features influence outputs. This is a significant departure from traditional fine-tuning, which requires altering model weights through retraining, according to CTGT. This method offers two main advantages. First, the changes take effect instantly without requiring hours or days of retraining. Second, the model can be toggled between different behavioral modes on demand, allowing a single model to meet multiple safety or policy requirements across different use cases. This level of real-time behavioral control presents new opportunities for sectors like healthcare, finance, and national security, where regulatory compliance and alignment are critical. However, it also introduces new risks, particularly when applied to models already under regulatory scrutiny, by potentially enabling sensitive content generation that the original model was explicitly designed to avoid. Real-world industries implications for industries. The ability to toggle censorship off in AI models isn't just a technical milestone. It introduces serious changes for enterprise and institutional use cases in industries like finance, healthcare, cybersecurity, and law enforcement. Access to uncensored, precise information can be critical. Traditionally, companies needing this level of control would invest heavily in fine-tuning models for their specific domain, aligning responses with internal policies or regulatory standards. That process is time-consuming, expensive, and not always flexible. CTGT's approach eliminates that bottleneck. Since the censorship filter can be adjusted in real time, businesses can deploy a single model across multiple environments and simply toggle censorship levels depending on context. For example, a hospital AI assistant could be set to deliver direct medical advice for internal doctors while giving safer filtered outputs for patient-facing chatbots. Financial institutions could reduce overfiltering when analyzing geopolitical data or regulatory frameworks. Even in cybersecurity operations, teams could use models to investigate controversial or high-risk threat vectors without triggering internal response suppression. CTGT argues this level of dynamic behavior makes their method especially useful for high-risk AI deployments, where both transparency and policy compliance are essential. According to the company, their method helps prevent unnecessary information gaps without compromising overall safety. At the same time, the ease of uncensoring raises questions about how these models could be used or misused by actors who don't share those goals. National security risks, and ethical challenges. The timing of this breakthrough is notable. Just weeks before CTGT's announcement, the U.S. Congressional Select Committee on the CCP released a report specifically naming DeepSeek as a model with unfiltered and potentially dangerous capabilities. The report warned that such tools could be used to disseminate state-aligned propaganda, misinformation, or even help in espionage. The committee called for tighter export controls, improved monitoring of AI model usage, and greater scrutiny of open-weight models developed abroad, especially those from adversarial states. One concern is that these open-source models, once uncensored using techniques like CTGT, could be repurposed by malicious actors. The concern isn't hypothetical. Researchers have previously shown that language models, when manipulated, can generate convincing phishing emails, create malware, or spread disinformation at scale. And while CTGT's method doesn't introduce those behaviors, it does remove the built-in resistance that previously prevented such content from being generated in the first place. It's also worth noting that CTGT's paper doesn't promote unrestricted use. The researchers emphasize that their method can be used responsibly and even allow for fine-tuned partial censorship, not just full removal. But from a regulatory standpoint, the discovery still opens new ethical and geopolitical questions. Who decides which features get turned off? How do governments ensure responsible deployment when powerful AI tools are increasingly modular, customizable, and publicly accessible as AI behavior becomes more programmable at runtime? The concept of alignment becomes harder to define and harder to enforce. Industry regulation and government reactions. While CTGT's research is still being evaluated in peer review circles, it's already attracting attention from major AI labs and regulators. The company has confirmed it's working with a leading foundation model lab, though they haven't disclosed which one. Their stated goal is to help make future models more trustworthy and safe from the core. Meanwhile, global governments are adjusting their posture toward AI safety. The White House executive order on AI issued in late 2023 called for stronger alignment protocols, auditing mechanisms, and restrictions on export of powerful AI systems. The European Union's AI Act, passed in 2024, classifies high-risk AI applications and mandates transparency about training data and alignment strategies. Neither of these regulations, however, anticipated a technique like CTGT's, which doesn't involve retraining or tampering, but rather inference-level modification. Some industry experts argue that this method could become a compliance feature in itself, giving companies more control over AI behavior without sacrificing scalability. Others warned that it could become a backdoor, allowing organizations or individuals to quietly bypass restrictions embedded by model creators. Platforms like Meta and Mistral, which release models under permissive licenses, now face a dilemma. If model behavior can be altered this easily, will developers need to start hard coding protections at a deeper level, or does the future lie in giving users more control at the risk of safety trade-offs? For now, CTGT's method remains a research-level innovation, but the conversation it sparked is already reshaping how companies, regulators, and developers think about AI control. What comes next comes next. For AI, the ability to dynamically remove censorship from AI models doesn't just change how AI is used, it changes how it's governed with the flip of a switch. Models that once refused to answer sensitive questions can now respond freely, and this transformation can happen without modifying the model's code or structure. CTGT's approach is not illegal. It doesn't exploit a bug, nor does it inject false information. It simply reveals how flexible and programmable AI has become at its core. But that flexibility, while valuable in many enterprise contexts, raises new challenges around transparency, regulation, and unintended consequences. As of now, the technology only works on open-weight models, meaning it can't be applied to proprietary systems like GPT-4 or Claude 3 unless those companies allow direct access to the model internals. But the growing availability of open models like LLaMA 2, Mistral, and others means this kind of modification could become increasingly common. Researchers and policymakers are now grappling with the central question: when safety mechanisms can be turned off like a light switch, how do we ensure they stay on when it matters most? That's the new frontier for AI. Not just smarter models, but more controllable ones. Whether that leads to safer systems or new vulnerabilities will depend on how this capability is handled in the months and years ahead. If you've made it this far, let us know what you think in the comment section below for more interesting topics. Make sure you watch the recommended video that you see on the screen right now. Thanks for watching.